Hello friends, my name is Shri Prakash Singh and welcome back to our YouTube channel BI and DataScience.com. In today's video, we are going to cover difference between analytics, data science, machine learning, artificial intelligence and other related terms. I'll be covering all these differences from theoretical perspective. I'll explain each of them briefly with their historical evolution and backgrounds. If you watch this video till end, I can promise you'll not only understand the difference between them, but you'll also develop a clarity around how they overlap and how do they interact with each other. So stay tuned, I'll be back after a very short intro. The world is running on data, and these days you would be listening a lot of buzzwords like analytics, data science, machine learning, AI, generative AI. Then don't get confused. After watching this video, you will have a complete understanding about all of them. Now, it is important to remember these are all technological fields, and people who practice in these areas or in these fields are often called as data analysts, business analysts, data scientists, machine learning engineers, AI engineers, and so on. If you want to learn about these roles in a business context and what they do, then watch this video. The link is put in the description. For a continuity and ease of understanding, first we'll understand the difference between analytics and data science. Then we'll understand difference between data science and machine learning. And finally, we will cover machine learning, artificial intelligence, neural network, deep learning, generative AI, because they're all subset of AI. So let's dive in, understanding the different terms. So we'll understand analytics, data science first, and then we will consider all around ML, AI, Gen AI, deep learning, and everything else, like how they are all interconnected and which one is a subset of what. Okay, but before we go there, let's understand how analytics started. Like, what were the reasons that fueled the growth of analytics? And at that time it was all called big data actually. So if you think about a journey, we had data. So first there was a data revolution, and data revolution started from your ERP platforms. Now, what happened originally was like when automation and computerization started to happen with all the ERP, CRM, and big software in places, we started dumping a lot of data very soon. And when the big data came in, we obviously talked about terms like V's, right? The velocity, the volume, variety, and then we have something called veracity. Now, volume is like it's the magnitude, the volume of data that was getting dumped from these systems, and with the speed, like data was refreshed first on a daily basis. Then we started taking at a shorter and shorter interval from hourly to minutes, and now some of the telemetry events, they even come at a seconds interval, right? So all of this led to an explosion in data, right? So we had different kind of data with different attributes at a huge volume and at a huge scale. So this data revolution was what it resulted in. Organizations had a lot of data, but they were thinking what to do with this data, how to make use of this data. And in order to do though, we heard something around big data. So this was the time when data mining and all of these terms were coined. And also the other reason for big data explosion was the storage cost kept on going down. Need for analytics came in. So even though this data was cheap, the question was still like, if there is no ROI of storing this data, what's the use? So the idea came, let's start using this data in some way. And that's how the analytics came in place. So the first idea was, what kind of intelligent information can we make from this data? So what happened was, the first thing was we started making dashboards, charts, visualizations, right? And this would give a lot of business information around how things are working and how not. So the growth of big data led to the need of using that data, and that led to what we call as the pyramid of analytical needs. So what was happening was, at the bottom of pyramid we had massive data with all the v's, right? The volume, velocity, variety, veracity, right? All of the data was there. So the first analytical need was to understand what what is happening in my business. And to solve that, we started to develop a lot of KPI reporting, dashboards, data summary, right? And those things. So this was called as the descriptive analytics. Then once we understood this, then the question was, why? Why does it happen? So this is started into doing a root cause analysis, data exploration, and what you call as diagnostic. We started analyzing, right? Analytics. So until this point, this was the realm of what we call analytics. Even though we'll call the other two needs as analytics, but this is where things start to become interesting, because once we know what's happening in my business, why is it happening? If you know why something is happening, you can predict when it will happen or what happens next, right? So then came, can we predict when what will happen, right? This is called predictive analytics, but this is the space where it overlaps with data science, right? Because to do the predictions, we need to bring in the concepts from mathematics, statistics, right? To do all kind of inferences, we need to understand the how the event is distributed, and the underlying distribution probabilities, and then we construct a model using a lot of mathematical techniques like error minimization, what we call as linear regressions, right? So to predict when what will happen, this is the realm where it starts overlapping with data science. Because to answer or to predict, we need to bring in concepts from mathematics and statistics. Now, given we understand when, if we can predict when something will happen, then the question came in, can we be more prescriptive? Like we want to say when, what, and for whom, right? So this is also called as personalization, right? Which we'll be talking a lot in coming videos. So these two top needs is data science, and mostly they are done by data scientists. And these bottom two needs, The descriptive and diagnostic, the dashboarding, summarization, reporting, data exploration, aggregations, data cleaning, stitching, right? All this is done by analysts. Now, I told you in another video what's the difference between a business analyst and a data analyst. If you haven't seen that video, the link is in the description. Now we understand difference between analytics and data science. So now let's go and understand the difference between data science and AI, and then we'll come data science and machine learning. And this is very interesting, guys. They they use similar technique but different approach. They use similar technique but different approach. What do I mean by that? I'll explain you. So remember in my previous video when I talked about different careers, and there I talked about a data scientist and a machine learning engineer. The analogy that I gave you was, think of data scientist as the scientist in life and the machine learning engineers as the engineers in life. So scientists do the research about gravity, friction, and everything, and the engineers make technology on it. So they make the fulcrum and lever, and they use all the fundamental research from here, and they apply and they solve the real life problem by building some products, tools, etc. So that's the difference between the approach of the practitioners of these two disciplines. Now, understand the basic concept is scientists are more research oriented. Their idea is mostly coming from theory, and engineers are more application oriented. So bulk of their knowledge is coming from customers. And how are customers giving that knowledge? Is through data. This is the fundamental difference between a data science approach versus a machine learning approach. Now, what happens is data scientists will first identify a problem, and then they will go and start collecting data for that, either through survey or research. They first identify the problem, and then they go and find the data. That's their approach. What these guys do, what do engineers do? They first have the data, and then they try to see what problem can they solve, because the data is coming because of some problem, or the data is giving them insights of, oh, this might be the problem. If we remove this, then the problem will be solved, right? So it's kind of, you take all the spaghetti, throw it on a wall, and you see what sticks, right? That's their approach. So for them, data is first, and then problem is second, or insights is second, right? So this is the basic approach difference between data scientists and machine learning. Now again, obviously, why is this approach now more important, or why is it increasing now? That is because our compute cost has also come down. Okay, so the storage cost improvements or reduction in storage cost led to the revolution in big data. Reduction in compute cost fueled the growth of machine learning. Now, again, we'll see machine learning is kind of when machines are trying to learn, but what machines are trying to do is they are taking all the algorithms that data scientist or engineer that were in the research domain, they are taking all those algorithms and then they are trying to fit all those algorithms on data to see if they can come up with some pattern or if they can identify something in that data, and then based on those identification process they further go and try to solve the problem. So now we understand the difference between business analytics, data science, and machine learning. Now let's see how is this all related to AI. Okay. AI or artificial intelligence is nothing but when machines have the ability to think like humans, right? That's a broad umbrella where we call it an artificial intelligence, because in all the living creature on this planet, I think we only believe human beings have so-called consciousness, which we define as the intelligence, right? So if machines starts behaving like human, it means we they are representing some form of intelligence, and because they are non-living things, we call it an artificial intelligence. Now, is it accurate to call it an artificial intelligence because it is an intelligence? That's a whole different debate. I think we should cover in another video. Okay, so think of artificial intelligence as the broad spectrum of everything where machines have some way of mimicking something that a human, like a data scientist, will do, right? So, in that broad space, ML is one component, machine learning is one component, because machine learning is ability where machines are using all kinds of different algorithm on data and they are trying to come up with some pattern recognition. It's like this. There are two approaches to machine learning. There is supervised learning and then unsupervised learning, right? So in supervised learning, what is happening is we tell machines, we give machines example like this is cat, this is dog, this is rat, and we train the computer on millions of images of cats, dogs, and then in the end the machine can recognize if we show it any new picture of a dog or cat that machine has not seen, it can tell whether it's a dog or a cat, right? So that's supervised learning because we are training the machine. We are telling in initially what is what. We are telling the examples. Unsupervised learning is where we don't give any insights to machine. In the training, we are not telling the outcomes and we are letting the machine learn on its own. Like this is like think of unsupervised learning as a test on rats. You keep a food in front of rat and you ring a bell, the rat comes, eats. Next time you again put food, ring the bell, it comes, right, and eats the food. Third time you ring the bell, the cat will come even if you don't put the food, right? Because that's how it's learning. So all those learning techniques are called are part of unsupervised learning. They are all examples of unsupervised learning. Now there is another area in machine learning which is neural networks, right? So neural network is where we try to mimic human brain because our brain functions on the basis of neurons, right? So neural network is a very old concept. Like it's not new. The original research about neural networks date all the way back to 1970s, right? But their growth again is happening nowadays because of the cheaper compute power, right? So a lot of neural network is unsupervised learning, right? If we make the umbrella of unsupervised learning, a lot of neural network models are trained on unsupervised learning. But what happens is, because we make many layers of neurons, right? And then these layers can work with another neurons, and then they can work with another neuron, and then so we can make many layers, right? Layer after layer. So this is what we are doing. We are making a deep network of neurons. So more layers we add, we say our model is becoming deep. And that's why we call this as a deep learning. So deep learning is all those area of unsupervised learning where we are using neural network and unsupervised learning, and including many layers of neurons to learn the process, right? So that's a deep learning. Now, within deep learning, we have all these models of CNN, convolutional neural network, RNN, right? We will learn all of these concepts in coming videos. So, given this deep learning, there is another architecture. So far, we have seen AI is the big space, and within AI, machine learning is a subset. At the intersections of machine learning and neural network and unsupervised learning, we have deep learning. And within deep learning, we have Gen AI, which is the generative AI. So, what does generative AI now do is, because using a deep layer of neurons, and we are talking about hundreds, millions, and billions of parameter in the model, right? We are able to show, we are able to train the machines to show behavior that are very close to human behavior. So far, we have understood the difference between analytics and data science. We understand the difference between machine learning, neural network, deep learning, and artificial intelligence. And we also talked about generative AI. So, generative AI, if you talk about, uh, we are talking about Gen AI, they are an example of deep learning, machine learning, and AI. So, Gen AI is here. So, this is your AI, this is your machine learning, this is your deep learning. Now, generative AI is at the intersection of all of that, right? Now, this is how it's trained is they are very complicated, very deep, billions of neurons in a very deep layered sequence, and they can be trained on anything. So if you train them on text, and if you ask them a question, they can predict you what will be the coming text. Like if you train it on, like for ChatGPT, the example is ChatGPT, right? You ask a question and it is trained on all kind of text data, so it will generate text. Now if you train it on image, it can generate your image, right? Because if you train it on all kinds of image, like this is cat, this is dog, this is building, this is office, this is boy, this is ball, right? You train it on all the images, and now you ask it, okay, generate an image where a boy is holding a ball and the dog is standing next to him. It can generate that image, right? So they are called unimodal, right? From text to text, image to image, and then if you train it on video, of video. Okay, DALI is example of your image, right? So here the example is DALI, and here Sora is your example, right? And there are many Mid Journey, and there are many models that are trained on video and they can generate a video. So similarly, if you train them on voice, they can generate voice. So that's why they are all called generative model, because they can generate the next sequence of what they are trained on, right? And then you can have multi-model. So you can ask a text to generate image, or you can give a voice and you can ask it to create a character with that voice speaking, running, right? So when you mix and match all kinds of formats, it's a multi-model generative AI model. Let's put everything in perspective. So we saw a field of analytics, then we saw the field of data science, and then we have, say, a field of machine learning. This is ML, this is DS, and this is analytics or BI, right? So here, what do we have in this space? We have okay. So what do we have in this space? We have the descriptive and diagnostic analytics, right? Here we have predictive and prescriptive analytics, right? And then we have a lot more that is not part of analytics in data science, like we have hypothesis testing, we have inferencing, we have inference, right? And a lot of other things, Bayesian theorem, we have Bayesian statistics, and several other things, right? Now, on the machine learning, if we look at the combination of machine learning and analytics, what do we have? We have automated recommendation systems, right? They work in combination with business knowledge, business insights, along with ML algorithms. And when we look at the intersection of data science and machine learning, we have all your neural networks, right? Neural networks, deep learning neural networks. And here at the core of everything, what do we have? We have Gen AI. We have all the algorithm, pattern matching, and right, supervised ML, right? So this is how they all interact with each other. So this is a complete picture of how analytics, data science, and machine learning, they interact with each other, they overlap with each other, and how they are different with each other.
If you are looking to build a career in analytics, data science, machine learning, or artificial intelligence, you are in the right place. These are some of the most exciting and in-demand fields today, but success requires more than just passive learning. Let's be honest. Self-study through YouTube or pre-recorded courses on platforms like Coursera, DataCamp, or Udemy can only take you so far. Why traditional online learning falls short? First, there is no real-time feedback. Mistakes go unnoticed, and bad coding habits develop. Second, there is a lack of accountability. Motivation fades, progress slows, and subscriptions often expire without being fully used. Third, there is no personalization. Generic training does not highlight your strengths or address your weaknesses. Finally, there is zero interaction. Watching videos alone does not make you job ready. To address all these issues at BIandDataScience.com, we offer an industry-relevant curriculum designed to make you job ready in just 9 months. The program includes 40 live interactive sessions where you can engage in real time, ask questions, and gain clarity. Each session is structured with 45 minutes of instruction, followed by 15 minutes of questions and answers to ensure maximum understanding. Classes will happen on weekends depending on which track you choose. Seats are limited, and exclusive discounts are available only for the first 100 registrations in each cohort. The next cohort begins on March 1st week and runs through November 1st week. Secure your spot now using the link in the description. For learners in India who face difficulties paying via credit card, email us for NEFT or ARG's payment details.
Friends, after watching this video, hopefully all your questions around differences between data science, analytics, BI, machine learning, AI, they're all resolved. If you learned something new in this video or something inspired you, then please like, subscribe, and share the channel. And don't forget to hit that bell icon because you don't want to miss awesome videos like this that our team would be creating in future. Thank you for watching. Stay safe, stay warm, and keep learning.